All right, so this is going to be part 2 of the lesson on rational functions. This is discussing what happens when you have a double asymptote with the rational function. I have my example, the function f of x equals 2 over x squared minus 1. And I'm going to go ahead and find very quickly my 6 pieces of information, including a possible test point. But the test point will occur when I actually see it on the graph. So in this part, my vertical asymptote is the zeros of the denominator, which happens to occur at x equals 1 and negative 1. My horizontal is comparing the degrees again. There's a 0 degree on top, 2nd degree on bottom. Since the top is less than the bottom, my horizontal asymptote is still at y equals 0. My y-intercept, plugging a 0 into x, would be 2 over negative 1, or the y-intercept is 0, negative 2. X-intercept would be the zeros of the numerator, but because there's no x in the numerator, there is no x-intercepts. So I'll put none. And then domain, which would be x contained in the set of all real numbers, except x not equal to the vertical asymptotes, which are 1 and negative 1. And then the range, y contained in all real numbers, except y not contained, or not y not equal to 0. Okay. So we have our 6 pieces of information, which of course is my 6 deadly sins of rational functions, and I'm going to go ahead and start graphing these things. So my vertical asymptote, I'm still going to draw vertical lines that are dotted, and I'll draw these on my graph. These occur at x equals negative 1 and x equals 1. And then my horizontal, which is at y equals 0. So to the left and to the right of the graph, we're going to kind of treat the same as we treated the last one in part 1. We'll go ahead and graph the y-intercept. We'll see if we can't get some curvatures to the right and to the left. So let's see, my y-intercept is at 0, negative 2, which would occur in my graph right here. Now that is inside the asymptotes. And so what's going to occur inside there is that we're going to have a parabola. And the question is this parabola going to be curving up? Are we curving down? And in order to actually figure that out, we're going to do again what's called a test point. Now I want to figure this test point out by a point that's going to curve between 0 and the next asymptote, which the next asymptote happens at 1. So I want an x value that is between 0 and 1. And if it is above negative 2, I know this thing is going to curve up. If it's below negative 2, I know it will be curving down. And so I'm going to go ahead and choose 1/2, and that seems to be the easiest point to choose between 0 and 1. So my test point is 1/2. And so I'm going to find whatever f of 1/2 is equal to. Substituting a 1/2 into my function, I'm left with this, and now I just need to simplify. Simplifying, I'm left in the denominator with 1/4 minus 1. 1/4 minus 1 is the fraction negative 3/4. And then flipping my denominator and multiplying will give me negative 8/3, which is roughly 2 and some change. So it's negative 2 and some change, which I think would be negative 2 and 2/3. But the point is that it is going below this red dot, because this red dot is at negative 2, and negative 2 and 2/3 would be a little bit below that. So what that tells me is that this parabola is shifted downward. Not shifted, it's going downward. That still doesn't answer the question of what's happening to the left and to the right of the asymptotes though. We know over here to the right that this curvature is either going to occur on top or on bottom. And since we don't have any points over there to tell us which way, I'm going to have to create another test point. I would like to choose something that's to the right of my asymptote. Since we already have my asymptotes at 1, I'll just choose the next integer, which will be x equals 2. I think that would be the easiest to try. So I want to go ahead and put inside my function f of 2. F of 2 is going to be equal to 2 over 2 squared minus 1. Which simplifies down to 2 over 4 minus 1, which is just 2/3. The fact that that is a positive 2/3 tells me what I need to know. Since it was positive, it will not be below, it will be above, and I can go ahead and graph my curvature. And I'll try and make this go as close to the asymptotes as possible, and with arrows to kind of tell you that they are going on forever. So now, if you want to choose other test points, you could have. You could chose 3, 4, 5. You could have chose 100, 1,000,000, whatever you want. And every single time you chose that, it would have been positive. I'll go ahead and go now to my left. Again, this can either be positive or negative, so my curvature can either be top or bottom. I just need to create one more test point, my very last one, to tell me everything I need to know about this graph. So now my test point, and I'm going to choose something to the left of this asymptote. My asymptote occurs at -1. I'll go to the next integer, which would be -2. Now, just by inspection, it's going to look like this is going to be positive because we did a 2 squared, and a -2 squared is also positive, but we'll go ahead and check it out. F of -2, which is 2 divided by -2 squared minus 1. Now, for those that are going to be using calculators that are not in my class, you want to make sure that you have parentheses around -2 in order to make sure the calculator is doing what you want it to do. Because this is -2 squared, not 2 squared, and make it negative. This simplifies down again to 2 over 4 minus 1, or 2/3. Since this is positive, I know that my curvature above here is also positive, or above the x-axis, and I can now finish my curve. Now, as this is a pre-cal lecture and this is a pre-cal class, there is one other piece of information about this graph that y'all will not be able to do immediately. Now, I agree that this point right here is going to be the top point of this parabola, and the reason I know that is because that this actual graph is an even function. So there is some symmetry about the y-axis. However, that is not the case every time. In fact, this is what this is called as a local maxima. And to actually find a local maxima, you're going to have to do what's called the derivative test and second derivative test. Because y'all do not know how to take a derivative, this is pre-cal, not calculus, I'm not going to require y'all to be able to tell me where the local max and local min is, because you would have no way to do that without a calculator. Instead, as long as you get, if it's going down or going up, I will count that as right, and that at least gives you the general idea, and I'll let your calculus teacher tell you how to find that last piece of information.